we're going to get to the second derivative test, but before we can do that, we actually need to define what a second derivative is. So if we have some function f of x that has a derivative f prime of x, and that derivative f prime of x is also differentiable, we can take the derivative of it, then the second derivative, the piece that we're trying to actually define, has either prime notation of f double prime of x. So remember, we use just f prime as Newton's notation for taking the first derivative, or in the second case, Leibniz notation, a second derivative would be d2y over dx squared. Remember, for Leibniz, it's where dy dx is the first derivative. Okay, so let's go through a couple quick problems of finding the first and second derivative. So if I have x cubed minus x, then the derivative would be 3x squared minus 1. So now when I want to take a second derivative, I'm only focused on the 3x squared minus 1. And if I take the derivative of that, I'm just going to get 6x, right? We'll have the 3 times the 2, and the x just goes to a 1, and the derivative of minus 1 is 0. Same process for part B. I'm going to take the derivative. Oh, wait, this is an exponential, right? The x shows up in the exponent. So first I copy the question, take the natural log of the base, which is just e, and take the derivative of the top. So the derivative of 5x is just 5. We know the natural log of e is 1, so I actually didn't even have to write it. I just do this for the notes for clarity. But in the end, my derivative is 5 times e to the 5x, right? We just tend to move that end 5 out front. So now when I go to take the second derivative, I look at the question. Now it feels like maybe you could split this into a product rule where the first part is 5 and the second part is e to the 5x. But the reason we use the product rule is when you have an x in both terms. And 5 by itself does not have an x. We're just leaving that like a lead coefficient and focus on taking the derivative of e to the 5x, which we just did. Copy the question, natural log of the base, derivative of the top. Derivative of the natural log of e is just 1, but this time we can multiply the green 5 with the red 5, so that in the end our answer is 25 e to the 5x.